Let's recap section formula. Now section formula is when we have a line segment AB and the endpoints of the line segment A and B have some coordinates, let's say x1 y1 and x2 y2, and there is a point P in between the line segment AB. So the point P is dividing the line segment AB in some ratio, and let's say the ratio is m:n. According to section formula, we can find out the coordinates of point P, the x coordinate and the y coordinate, if I know the coordinates of the endpoints A and B and also the ratio of division, what is AP is to BP. So with this given information, the coordinates of point P, so the x coordinate we can find like this. We can take m, the first part of the ratio, multiplied by the x coordinate of the other point, that is x2. So the x coordinate of point P will be mx2 plus n multiplied by x1 whole divided by the sum of the parts of the ratios m plus n. In the same way, to find the y coordinate, we will look at the y coordinates this time. So suppose we are looking at m multiplied by y2. So we will have my2 plus n multiplied by y1 divided by m plus n. So section formula gives us this coordinate, x coordinate and y coordinate of point P. Now extension of section formula is midpoint formula, where let's say that point P is the midpoint of AB. Then the ratio of division is 1:1, and I can apply m equals to 1 and n equals to 1 in section formula, and I can easily derive midpoint formula. So looking at section formula, mx1 mx2 plus nx1 by m plus n. Here m value is 1, n value is 1. So if I substitute that, the x coordinate of point P will become x2 plus x1 divided by 1 plus 1, which is same as x2 plus x1 by 2. And the same way, the y coordinate will become y2 plus y1 divided by 1 plus 1, that is 2. So we can write it as the sum of the x coordinates by 2, which is also same as the average of x coordinates and average of y coordinates. That's going to be the coordinate for point P, which is the midpoint of AB. Now going to equation of a line. Here we are looking at a linear equation in two variables x and y. So the general or the standard form of a linear equation in two variables is ax plus by equal to c. Ax plus by plus c equals to 0. My variables are x and y, and the coefficients of x and y are some numbers a and b, some real numbers a and b, and we also have a constant c. So a, b, c belong to real numbers. It can be positive, negative, rational, irrational, or even sometimes 0. Now graphically, any linear equation in two variables will look something like this. If I draw the xy axis, then any equation, any linear equation in two variables will be a straight line. Now we have a concept of inclination and slope. So suppose I represent an equation graphically, it's going to be a straight line. Now if I look at what is the angle made by that line with the positive direction of x-axis. This is the positive direction of x-axis. So let's say this is the line and this is my x-axis. So the angle in between is theta. Let's say the angle is theta. So I will say that inclination of this line is theta degrees, and slope of this line will be same as tan theta, which is written as m. Now suppose if I knew the coordinates of 2 points on the line, or if I knew two solutions to the linear equation. For example, if I take a coordinate a, x1, y1, and another coordinate b, x2, y2. If I know that these 2 points are on the line, then the slope of the same line is equal to, so the slope is equal to the difference of the y coordinates, y2 minus y1 divided by x2 minus x1. It is also same as y1 minus y2 by x1 minus x2. So this is the concept of slope. Now we can look at a pair of lines. So either a pair of parallel lines or a pair of perpendicular lines. In case of parallel lines, since let's say L1 and L2 are parallel to each other, and if L1 makes an angle theta with x-axis according to our geometry properties, let's say corresponding angle properties, even L2 will make angle theta with the x-axis. So they have the same inclination. So I can say, let's say M1 was the slope of line L1, M2 is the slope of line L2. Since they have the same inclination theta, both will have slope tan theta. So I can say that M1 equals to M2. Slopes of parallel lines must be equal. Now for perpendicular lines, let's say that L1 has an inclination of theta and L1 and L2 are perpendicular, then L2 will have an inclination of theta plus 90 degree. And if you apply the concepts of trigonometry, it can be derived that the product, let's say L1 has slope M1 and L2 has slope M2, and L1 and L2 are perpendicular lines, then the product of their slopes M1 multiplied by M2 is always minus 1. So we can apply these concepts for parallel and perpendicular lines. Then we have the topic of forms of equation of a line. One form we already saw previously is the general or the standard form, ax plus by plus c equals to 0. But the equation can be written in other ways and for some specific reasons, and also to get some information. First form is the slope-intercept form. Slope-intercept form means, suppose I know that this line L1 has slope which is equal to m, and the y-intercept of the line is equal to c. Y-intercept means the distance or the length that the line cuts off on the y-axis. So suppose here the line cuts the y-axis at some point over here, let's call it A, and we have the origin O. Then the length OA is called the y-intercept, and that is denoted with a variable c. If I know both these information, what is the slope and what is the y-intercept, then the equation of this line can be written as y equals to mx plus c, where m is the slope of the line and c is the y-intercept. For example, if I had a slope of a line m equals to 2 and the y-intercept c equals to minus 3, negative y-intercept means that the line is intersecting the y-axis below the origin. Let's say that it was like this. So, and if this point is 0 comma minus 3, then there is a unit, there is a length of 3 units but below the origin. So that y-intercept can be thought of as minus 3. So if I have this information, then I can tell that the equation of this line will be y equals to 2x minus 3. This is the slope-intercept form of an equation. Then suppose if I know any form of an equation but not the slope-intercept form. For example, we have the standard form of an equation given to us, 5x minus 3y plus 2 equals to 0. I can always rearrange the terms in the slope-intercept form, which is y equals to mx plus c. So I want y on one side and everything else on the other side. So if I look at this equation here, this minus 3y, if I move to the other side, it becomes plus 3y. So this is same as 3y equals to 5x plus 2. And if I move the 3 to the other side, I will have y equals to 5 by 3x plus 2 by 3. And if I compare with the slope-intercept form y equal to mx plus c, I can say that the m value will be 5 by 3 and the c value will be 2 by 3. So I can derive that this equation will have slope 5 by 3 and the y-intercept will be 2 by 3. So that's the concept of slope-intercept form. Then we have the point slope form. So the point slope form tells us that if I know the coordinates of one point which is lying on the line, let's say that is point A with coordinates x1 comma y1, and we also know the slope of the line which is equal to m, then the equation of this line will be y equals to we will have y minus y1 equals to m into x minus x1, where m is the slope of the line and x1 and y1 are the x and y coordinates of the point which is on the line. For example, if I know that there is a point A with coordinates 2 comma minus 3 on a line and the slope of the line is 1 by 2, then equation of this line will be y minus of minus 3, that will be equal to the slope 1 by 2 multiplied by x minus 2. So I just need to substitute the values of the x and y coordinates and the slope. The last topic is 2-point form. So 2-point form means I will know the coordinates of 2 points which are lying on the line. And if I want to find the equation of this line, I will look at the coordinates. Let's say point A has coordinates x1, y1 and point B has coordinates x2, y2. So given the coordinates of these 2 points on the line, first we will find the slope which is m, and if you remember that if I know the coordinates of 2 points, the difference of y coordinates divided by difference of x coordinates gives us the slope of the line. So first we will find the slope like this. Then out of these 2 points we can select any one point. It doesn't matter which point we select, we just need to select one point. For example, here if I select A with coordinates x1 and y1, then what do we know now? We know at least one point, the coordinates of one point which is on the line, and we also know what is the slope of the line. Then this becomes what we discussed, point slope form, and we can apply this point slope form to get the equation of the line. So here suppose with slope m and coordinates of point A x1 y1, the equation of the line will be y minus y1 equals to m into x minus x1. If I had considered point B with coordinates x2 and y2, I will get an equation y minus y2 equals to m into x minus x2. But if you simplify and rearrange, you will find that both of these equations will be the same thing. So this is a recap of all the concepts that you need to know for section midpoint formula and equation of a line.